Hello dear students, in the last class we discussed in the chapter pair of linear equations in two variables, that is exercise problems, in which today I am going to continue the same exercise of different examples. See here, exercise 3.2, in which third question. In the last class we discussed the two main questions. Now we are going to discuss third main question. So third main question is like this: on comparing the ratios a1 by a2, b1 by b2 and c1 by c2, find out whether the following pair of linear equations are consistent or inconsistent. So that you know the meaning of consistent. What is the meaning of consistent and as well as inconsistent. So here equations are given: 3x plus 2y is equal to 5, 2x minus 3y is equal to 7. These two are paired. 2x minus 3y is equal to 8, 4x minus 6y is equal to 9. These two are paired. 3 by 2, third one, 3 by 2 into x plus 5 by 3 into y is equal to 7, and 9x minus 10y is equal to 14. These two are pairs. 5x minus 3y is equal to 11, fourth one, minus 10x plus 6y is equal to minus 2, minus 22. These two are pairs. Fifth one, the last one, 4 by 3 plus 2y is 4 by 3 into x plus 2y is equal to 8. The next one, 2x plus 3y is equal to 12. So hence these are considered as pair of linear equations. Among them I will solve any two of them. Okay, take the first one. Solution. So here again I want to write the equation or pair of linear equations, that is 3x plus 2y is equal to 5. Okay, next one, 2x is 2x minus 3y is equal to 7. So call it as 1 and call it as number 2. Consider their standard form first before going to simplification solutions. Okay, so consider the standard form. Of course, x after y. So here coefficient reducible. Coefficients are already there. So 5 is a prime number. No need to again reduce it. So 2, 3 are prime numbers. 7 is also prime number. So no need to again reduce the given linear pair of equations. Now, so in order to finding whether these are consistent or inconsistent, first we can consider their ratios. So now the coefficients of pair of linear equations. Consider their coefficients. Okay, now the coefficients of pair of linear. Here a1 is equal to 3, b1 is equal to 2. Consider their sign also. c1 is equal to. So what happens? If you take this side, it becomes minus 5. Okay, so now here it is a2. Consider for the second equation, call it as a2, b2, c2. For first equation, call it as a1, b1, c1. So c1, why it become minus 5? So if you consider this term to this side, it become minus 5. So that is why. Otherwise, keep as it is. Consider c1 as 5, positive 5 also. So a2, 2, b2 is equal to minus 3, and c2 is equal to, again when it comes to this side, so means by transposing the 7 to left side, it become minus 7. Now on comparing the ratios means first of all consider the ratio and afterwards you can compare. So first now the ratios become, now what happened, a1 by a2, its value is 3 by 2. Now take another one, b1 by b2, its value is 2 divided by minus 3, and c1 by c2, its value is minus 5 divided by minus 7. It means it cancelled out. So therefore, consider here on comparing these all the given ratios, it would be appear like this: a1 by a2, b1 by b2, and which is equal to c1 by c2. Now consider, suppose you have to consider their ratios. When you are going to comparing the each ratios, substitute their value. So here 3 by 2 is equal to 2 by minus 3. Is it equal to 2 by minus 3? Yes, no, it is not equal. and also whether it is equal to 5 by 7? No. So that is why. So first consider if these two first a1 by a2 and b1 by b2 is not equal to each other. So consider their third also whether it is required or not. But here on comparing the ratios of first two ratios, so you will get some meaning. So that is why. So here it stops. Okay. You mean we already get some meanings of lines. That is here whenever the first a1 by a2 and b1 by b2 are not equal to each other. So based upon this we have to conclude the statement is like this: the given pair of linear equations are what kind of lines? Yes, they are intersecting lines. They are intersecting lines because their ratios are not equal to one another. So therefore the given pair of linear equations on graphical it is. Suppose you want to plot the graph of these two, the lines should be appear intersecting lines. That is why the given pair of linear equations represents that what they represents the lines intersecting at one point, so that given pair. So when you want to draw graphically of these two expressions or pair of linear equations, then the lines appear like this. Then that represents these linear equations represents that the lines intersecting at one point. It means therefore the given pair of linear equations are consistent. Why it is consistent? Why they are called consistent? Means they have a definite solutions. So for this purpose we may say that the given pair of linear equations, suppose they can represent on a graph, okay, the lines intersecting at one point, hence they have a definite solutions, means they have a solutions, unique solutions. So that is why the pair of linear equations are consistent. These two pair of equations is nothing but consistent pair of linear equations. Now consider the third one: 3 by 2x plus 5 by 3y is equal to 7. 9x minus 10y is equal to 14. So consider their coefficients. Okay. So consider their coefficients like a1 is nothing but 3 by 2. Okay. So b1 it is 5 by 3 positive, and c1 it is minus 7. Similarly a2 is equal to 9, b2 is equal to minus 10, and c2 is equal to minus 14, or positive both, because they are at the right side. c1 c2 values comes at the right side. So you can consider them positive or negative, because if they are shifted to this side, means left side, automatically they become negative. So that is why I took negative signs. So on comparing the ratios of ratio of what? Ratios means only ratios you can consider. Comparing the ratios only. So ratios of given coefficients. Okay. So that is a1 by a2. It is equal to b1 by b2. It is equal to c1 by c2. Now substitute these values. 3 by 2 by 9. Okay. So that is equal to b1 by b2 directly. Okay. b1 by b2 it is 5 by 3 divided by minus 10, and it is equal to c1 by c2. c1 by c2 means here minus 7 divided by minus 40. Simplified. So on simplification means it is already the numerator is given in the form of p. Consider p by q. So here if you express this in the form of a by b, so it should be appear like this. It is also same. So you know that the method of converting division into multiplication, what happened? So if you convert this division form into multiplications, the expression become like this. This three given terms become like this: 3 by 2 into, okay, this goes to the numerator and it comes to the denominator. And here also same, 5 by 3. Why I mentioned 1? Consider instead of that 9 by 1 is same value, 1 is denominator, because he represent this numbers are same. So that is why instead of any number I took 1. Here minus 10, instead of that minus 10 by 1. So 1 is 1. So converting this division form into, or these two only, because it is already in the form of p by 2. So here one more p by q came over here. Otherwise a by b. So in order to simplify these two ratios, so I will convert this division into multiplication. What happens in the multiplication? You know that the basic rule for converting the any division form into multiplication. This rule applies. So that is why 3 by 2 into 1 by 9, 5 by 3 into, so 1 by minus 10 is equal to minus 7 by minus 14. So here 7 minus 7 on the 7 to the minus 10. Here 5 on the 5 to the, okay. So 3 on the 3 to the. Look here. So here 1 by 3. Like this, because it is 1 into 1 1. 3 to the 6. It is equal to, here also 1 into 1, it is 1 1 into 1 1 divided by 3 to the 6. Okay, so 3 to the 6. But here negative sign is here. What? Negative sign. Okay, so here 1 by 2. It is equal to 1 by 2. Whether these are equal? Because 7 on the 7 to the, 5 on the 5 to the, 3 on the 3 3 the. So 3 to the 6, 1 into 1 the, 1 into 1 the, 3 to the 6, and plus into minus is minus. So therefore these are all not equal. It shows us again the given pair of linear equations represents that the lines, again the lines are intersecting at one point. Intersecting at one point. So that is why hence they are consistent. Hence they are consistent because of these assumptions. Okay, so because of these solutions, not assumption, these solutions, we conclude that given pair of linear equations, suppose you want to represent graphically, the lines appears, that lines represent, means the lines representing the intersection of lines. So that is why lines are intersecting at one point, hence they are consistent pair of linear equations. Now let us consider the fourth one. So the fourth one, I have already solved the third main, in which two examples, remaining two should be for the homework. Now consider for the fourth one. Out of this fourth question, I would like to explain any one. Which of the following pairs of linear equations are consistent or inconsistent? So for this purpose, what we can finding their coefficients. First find their coefficients and ratios, and as well as compare the ratios. Then, if consistent, obtain solutions graphically. If consistent only, you can draw the graph for the pair of linear equations. Otherwise, no need to represent all the pair of linear equations to graphic method. So first one, x plus y is equal to 5, 2x plus 2y is equal to 10. Second one, x minus y is equal to 8, 3x minus 3y is equal to 60. Third one, 2x plus y minus 6 is equal to 0, 4x minus 2y minus 4 is equal to 0. So fourth one, 2x minus 2y minus 2 is equal to 0, 4x minus 4y minus 5 is equal to 0. So by observing all these examples, okay, so take their coefficients, okay. First one, solution for the first one. X plus y, it is equal to 5. First one. Another pair of equation is 2x plus 2y is equal to 10. So now consider, okay. So how would you consider whether the given values are consistent, means pair of equations are consistent? The same method of the third way, okay. So consider the coefficients, okay. That is a1, call it as 1 and call it as number 2. So a1 A1 represents 1, B1 represents 1, and C1 represents 5. Here I take 5 arrays. So A2 is equal to 2, B2 is equal to 2, C2 is equal to 10. Okay. So now compare. On comparing the ratios of the coefficients. Comparing the ratios like this one, A1 by A2. So it is equal to, okay, 1 by 2, comma, B1 by B2, it is equal to 1 by 2, C1 by C2, it is equal to 5 by 10. So now simplify. So here values A1 by A2, it is equal to 1 by 2. So no need to again simplify this one, 1 by 2. Here C1 by C2 represents 5 ones are 5 2. So here all are equal. Therefore, our conclusion is like this: A1 by A2 is equal to B1 by B2, and it is equal to C1 by C2. Hence, what kind of pair of linear equations these are? Yes, the given pair of linear equations are. So given pair of linear equations. Consider equations. Okay. Equations are coincident. Why they are coincident? I directly written like this because here it is the given pair of linear equations. So on comparison their ratios. So we conclude that all the ratios are equal. It means the lines represents on a graph appear like coincident. So that is why coincident pair of equations these are all. Means the lines should be coincident. Hence coincident means what? What is the interpretation? The graphical interpretation is that, and as well as algebraic interpretation is that if lines are coincident, then they are consistent. So therefore the given pair of linear, okay, equations are consistent. Suppose they are the given pair of linear equations are consistent. Now you can take the x values and y value, because so graphically represent the linear equations into graph. So that is why I will do by graphical. So consider the first equation. Substitute the value of one variable, it gives the other one. Okay. So that is why here x for which one? X plus y is equal to 5. For x plus y is equal to 5. So here, you know that in our previous class I shown. So consider any numbers, whole number or integers. Okay, 1, 2, 3, 4. Take smallest numbers. Okay. Suppose you can substitute. Look at x plus 5. X plus 5. If x equal to 1, then y is equal to 5 minus x. So that is equal to 4. Isn't it? If x equal to 1, then y is equal to what happened? 5 minus x means 5 minus 1. So that is 5 minus 1 is equal to 4. So here it is 4. In the same way, if we put x equal to 2, y is equal to 5 minus x. So that is equal to 5 minus 2. So it is equal to 3. Means values increases x. If x values increases, y value decreases. So that is why 3. Next one is 2. Next one is 1. So you can get immediately the answers also. In the same way, now for the equation second, that is 2x plus 2y, it is equal to 10. Otherwise it will be same, because if you divide it by 2, what happens is x plus y is equal to 5. The same table column arises. So take for this also x and y values, okay. So here it is x. Consider their negative signs, minus 1. Not only positive, you can take the negative signs also. Minus 3, minus 4. So now substitute, if x equal to these values, minus 1, then what happens? Y is also minus half minus x. Okay, y minus x only. Here it is y minus x. So here 5 minus half minus 1, it becomes 6. So here I want to show only one solution. By using that you can write next one also. Okay, because 5 minus x means 5 minus half minus 1, minus into minus plus 5 plus 1 is 6. So what happened? 5 of minus half minus 2, if x equal to 2, minus 2 first 7. Value increasing. Okay, here decreasing, here value increasing. 6, 7, 8, 9, like this. So this is our tabular column. Okay, go through this tabular column. Now we would like to represent the graph of the linear equations. Here. Now take from this side. Okay. Okay, now so just now I draw the x-axis. Here it is first y-axis, and it is x dash, and it is y dash. Okay, along with the points 1 to 7. Okay, your scale is, consider the scale for x-axis and y-axis. Okay, one axis, 1 unit. Okay, 1 unit of 1 centimeter. Okay, consider. Suppose you can increase the units by 2, 4, 6 like this. You can take 2 units. The same way y-axis also. Here it is opposite signs, integers. Okay, minus 1, minus 2, minus 3. Opposite units, minus 1, minus 2. Here it is positive, here it is positive. X-axis positive, y-axis positive. X-axis negative values, y-axis negative values are represented like this. So now first table column, consider the x and y are coordinate points. So their points look like P, Q, R, S. Okay. So for 1 to 4, plot the point 1 to 4. Next one 2 to 3, 2 to 3. Next 3 to 2. Here it is 2. Here it is 3. Okay, 4 to 1. Here it is 4 to 1. Now join all these points. Yes, it seems to be. Okay, like this. Okay, now so this is what, suppose you want to write the coordinate point like this, 1 and it is 4. Okay, 2, 3. Next one 3, 2. Next 4, 1. So which axis it is? It is x plus y is equal to 5. First equation. The same way I represent the second one. Minus 1 to 6. So minus 1 to 6. Up to how much? 9 it is. So that we can increase the axis also. Okay. So I just written roughly, draw it properly through using the graph paper also. Okay. So here it is 7. Here it is 8. Consider the 9. Okay. So here minus 1. It means minus 1 to 9. Here it comes. Okay. Minus 1. Next term, minus 1 to 6 here. First term. Minus 1 to 6 means here. Okay. Here. Not here because minus 1 to 6 first term. Minus 2 to 7. Minus 2 to 7. So okay. Next term, minus 3 to 8. Minus 3 to 8. Minus 3 to 8. Okay. Minus 4 to 9. Minus 4 to 9. Comes approximately like this. I just written roughly. Okay. So consider it is a graph sheet. So along with x and y axis are written. It is a origin in which the plotted points are like this. So first equation is over. So it seems to be a straight line. What about the second one? Suppose you want to join, you can join. Join all the plotted points. Okay. Suppose you can extend it. Yes, I extended up to this. Here minus 4 to 9. Here it is minus 3 to 8. Minus 3 to 8. Okay. Here it is minus 2 to 7. Here it is minus 1 to 6. So here it is a separate line, here it is a separate line. But it seems to be the same line. Because this line represents this equation. This line represents these equations. Okay, this one is this one, this one is this one. Just I extended this line. Exactly this line and this lines are coincident, means merged. So that is why the consistent means what? Here consistent means whether the lines are intersecting or they are coincident. So that is why the graphical representation of the given pair of linear equations are represented like this. So this is the entire solution of the graphical representation for the consistency of the any pair of linear equations. So dear students, by these solutions I would like to conclude my class, today's class, that is third and fourth main is completed. In the next class I would like to explain the fifth and sixth and as well as seventh main questions also. What are the remaining questions in the third main, fourth main, you should do homework and practice thoroughly. So thank you.